Rhombus. So for rhombus, again, we're going to draw our diagonals. And this is just to help you visualize what all of the properties kind of together are. It makes it a lot easier. So for rhombus, the first thing that we know in a rhombus is that our opposite sides are all equal. So equal, 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 and equal. Property number 2 is that the diagonals are perpendicular. So 90, 90, 90, and 90. Okay? Last, the diagonals bisect the vertex angle, making this one and this one equal, and this one and this one equal. Make those dots a little bit bigger. There you go. And the same thing is true over here. These two are now the same in conjunction with these two. Now, it also inherits the parallelogram properties where diagonals bisect each other. So that means that this one and this one are equal, and these get 3 and 3. Now, these triangles are actually all identical. I've got 3 lines, 2 lines, 1 line. 3, 2, 1. 3, 2, 1, 3, 2, 1. All my angles are the same every single time. It's like copy and paste. So there's one set, and I'm putting ones in here to show that they're all equal. So you actually have 4 congruent right triangles hidden inside of a rhombus. 4 congruent right triangles. Those triangles are all identical. Let's move on down to rectangle. Again, we're going to be drawing our diagonals. And the diagonals in this case are not congruent, or they're not bisecting the vertex angles. But we do know that our first property is all these angles are 90. So all of these are 90 as a whole, but not as individuals. And they're not being bisected either. So that's property 1. Property 2 is that the diagonals bisect each other and are congruent, which means I'm going to put single lines here, 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 and here. Okay. Next, my opposite sides are equal. That's a parallelogram property. So I'm going to put double and double, and then over here, triple and triple. Notice that you have 2 congruent sides, which means this is actually an isosceles triangle, meaning that you've got congruent base angles here and here. Notice how triangles are everywhere. That's the great thing about kind of this last chapter, is it brings everything that you have learned together. We've already learned about isosceles triangles, but they show up again in circles. They show up again in rectangles. All the shapes kind of go together, which is a great thing about geometry. Everything kind of works together. So since you have an isosceles triangle and you have congruent base angles, alternate interior angles also exist, which means this one is congruent to this one, and this piece over here is congruent up here. It's kind of like you took your rectangle and just flipped it. Okay. The same pattern also exists on the left and right side. I have, again, 2 congruent sides and a different side right here. So this is my base, meaning these are my base angles, alternate interior angles, which show that this one is congruent to this one. And then again, by default, you still have those vertical angles. So this one up here and this one here, and then here and here. So rectangles, actually what's created within them are isosceles triangles. So 1 corresponds to 1, and 2 corresponds to 2. So you actually have 2 pairs of congruent isosceles. Did I spell that right? Yeah, I did. I always misspell it when I talk. 2 pairs of congruent isosceles triangles, and that's true for rectangle. So being able to just identify this information is very, very helpful. Last one is square. So again, I'm going to draw those diagonals in to make our lives a whole lot easier. Okay. Again, these are 90. Now on a square, it kind of combines everything. So all of the vertices are 90, but it also inherits this property from rhombus, making all of these 90 as well. Also, we know that all the sides are equal. That's the rhombus property. So equal, 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 and equal. Also, a square is a rectangle, which means the diagonals are also bisecting and congruent. So double, 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 double. Also, the diagonals are bisected, and actually what ends up happening, which is so cool with the square, is that you actually end up having these small angles all being the same, where each dot, each of those pink dots, is equal to 45 degrees. Because just like in a rhombus, the vertex angle gets cut in half. Half of 90 is 45 and 45. So you actually end up having 4 congruent right isosceles triangles, and they're actually going to be 45, 45, 90, because you have congruent sides making these two angles equal, which makes them 45, 45, 90 triangles. And I will put the ones in here, 1, 1, 1, and 1. And you don't have to put the ones, but it just kind of shows you that you have everything being equal. So this is all of the properties kind of visualized together. Matching the congruent colors means that the angles are equal. It kind of will just help guide you when you're solving problems. If you're like, okay, this is a rectangle problem, look at this picture, and it will kind of guide you in, do I set it equal? What do I know about the shape? It'll help you kind of figure out how to solve the problems. On page 19 and 20, we're going to talk about trapezoids.